Okay, we're now going to investigate the limit of a recurrence relation. So you'll know that for a recurrence relation given by un plus 1 equals aun plus b, that a limit exists when a lies between in minus 1 and 1, but not including minus 1 and 1. Okay, so let's just explain this through a few examples. Find the first 6 terms and the limit of the recurrence relation given by un plus 1 equals 0.6 un plus 12 when u0 equals 20. Okay, so we want the first 6 terms and then we want to find the limit. Okay, so u1 equals 0.6 lots of u0, which is 20 plus 12, and that will give me 24. u2 then is 0.6 lots of 24 plus 12, and that will give me 26.4. I've shown the working twice, so I can now let the calculator do the rest of the hard work. So for u3, that will then be 27.84. u4 will be 28.704. u5 is 29.2224, and finally u6 will give me 29.53344. Okay, the question is now asking me to find the limit. So first of all, let's establish that a limit absolutely exists because 0.6 lies between minus 1 and 1. Now if you think about if a limit exists from a recurrence relation, aun plus b as we know it, let's say we reach the limit at un. Well, that means that the next term after that would be the limit again, because by implication we have reached the limit. So that's not going to change. So if we reach the limit at un, then the following term un plus 1 will also be the limit. We can then say it's true that L equals AL plus B. Okay, so we know that A is equal to 0.6 and B is equal to 12, so that's then L equals 0.6 L plus 12. Can now bring that over. L minus 0.6 L is equal to 12. 0.4 L equals 12. L equals 12 over 0.4. We'd be looking to do that without a calculator. We can multiply top and bottom by 10. That will give me 120 over 4, and the limit is equal to 30. Okay, let's try another example. A sequence is defined by the recurrence relation un plus 1 equals 0.75 un plus 15. u0 is given by 75. Okay, so part A says calculate u2. Okay, so u1 is equal to 0.75 lots of u0, which is 75, plus 15. That will give me 71.25. u2 is equal to 0.75 lots of, well now 71.25 plus 15, and that will give me 68.4375. Okay, part B. Part B says, what is the smallest value of n for which un is less than 64? Okay, so the smallest value of n, which will generate un is less than 64. Okay, so I've entered the recurrence relation to the calculator twice, so the calculator will now recognise that that is a recurrence relation, so I'll just hit the equal sign again for u3, and that will give me 66.33 328125. Just repeat this process. U4 is 64.746 09375. U5 is equal to 63.55957031. Now we can see crucially that at U5 we've drifted below 64 and n is equal to 5. Okay, the question then asked me to find the limit for part C. Okay, does a limit exist? Absolutely, because 0.75 lies in between -1 and 1. Okay, so remember again that if we reach the limit at un, the following term will be the limit. So at that juncture, we can absolutely say that L equals AL plus B, given that L is the limit, and the next term will be the limit again, because by definition I've reached the limit and that won't change. Okay, so that's L equals 0.75 L plus 15, L minus 0.75 L equals 15, 0.25 L equals 15, L equals 15 over 0.25. I can multiply top and bottom before there and keep away from the calculator, and that will give me 60 over 1, and the limit is equal to 60. Okay, let's try a couple of questions in a worded context. Okay, first one, a local remand centre holds 350 prisoners at present. Okay, and that's at the present time. It's been estimated that this number will increase by 15% each month. During any month, 50 prisoners are released. Okay, so that's something that we can predict will happen. The centre is considered overcrowded if the number of inmates is greater than 400. Will the centre ever be overcrowded if this situation continues? Okay, so the limit then is 400. That's what the question's asking me to think about. If I go over 400, then it would be considered overcrowded with the current situation. Okay, so let's first of all set up a recurrence relation, which will allow me to calculate the limit. Okay, so the percentage is increasing by 15%, so that's 115% then up from 100 by 15, so that'll be 1.15 UN. So remember, UN plus 1 is the prisoner population, so it's grown by 15% each month in terms of intake. However, 50 prisoners are released, so we take away 50, so UN plus 1 equals 1.15 UN minus 50. Okay, so will it ever get overcrowded? I would suggest at that point that absolutely it will, since 1.15 does not lie between -1 and 1. Therefore, there is no limit to the population. So, yes, this centre will eventually become overcrowded. Okay, let's try another. A forestry company owns 100 hectares of woodland. Each hectare contains 60 trees, 60 mature trees, so 1 hectare equals 60 trees. To maintain stocks, the company needs to have 1,500 mature trees at any one time. So 1,500 trees are required. So that would be a lower limit then. It estimates that 25% of mature trees are felled each month. So taken down, chopped down, while 300 trees reach maturity over the same period of time. Okay, so first of all, let's go with the recurrence solution to answer the question. And the question is, will stocks be maintained at an acceptable level? An acceptable level, a lower level being 1500. Okay, so let's first of all get a recurrence solution. Okay, now 25% of trees are felled, which means 75% remain. Now, to compensate from this, 300 trees reach maturity, so that's 300 extra trees plus 300. Let's now investigate the limit. So L equals 0.75 L plus 300. L minus 0.75 L equals 300. 0.25 L equals 300. L equals 300 over 0.25. I can multiply top and bottom before, and that will give me 1200. Okay, so since 1200 is less than 1500, the number of trees will not reach an acceptable level. The number of trees will drop to, as we can see, 1200.